All right, so we learned yesterday about conditional sentences. Conditional sentences are made up of if and then. What else is a conditional sentence made up of? It has two parts. What's the first part?
Hypothesis.
A hypothesis. So whenever we're labeling a hypothesis, what letter do we use? P. Then we have the second part of the sentence, which would be a conclusion, which we do represent with the letter Q. And then we also learned about negating. What was the negating symbol? A little squiggle. So when you negated, if I said your hair is blonde, okay, the negation is your hair is not blonde. If I said your pencil is not on the floor, the negation would be your pencil is on the floor. Good. So with the conditional sentence, which is the first one, what will come first, the hypothesis or the conclusion? The hypothesis, and then the conclusion. So what will my sentence look like for my conditional?
If you do your math homework, then you will do well on the test.
Good. If you do your math homework, then you will do well on the test. Okay. The next one with a converse, what's going to come first, hypothesis or conclusion? Conclusion, and then the hypothesis. Do I switch the words if and then? No. I still start with if, so my sentence would look like if.
You do well on the test, then you did your math homework.
Yeah, so if, I said if you did twice. So if you did well on your on the test, then you did your math homework. You could also say do and do, but I would not say if you will do well on the test. That doesn't make sense. So you can always change the verb, the verb tense, if necessary. The inverse, what do? We negate. And we're going to have the hypothesis first and the conclusion second. So if, what?
You did not do your math homework, then you will not do well on the test.
Good. If you do not do your math homework, then you will not do well on the test. And then contrapositive, where we're going to do both. You switch them and you negate them. So if, and then your negated conclusion comes first. So if what? If you... Good. If you did not do well on the test, then you did not do your math homework. Good. You're going to put this aside for now. So without an equal sign, you don't really have a purpose. You're not solving for anything without an equal sign. The next term you have is solving an equation. So when you're solving an equation, what is your goal? What are you solving for? Yes, but what does your answer look like? X. It looks like a variable. It looks like a letter. So whenever you're solving an equation, you don't have to write all of this. You're finding the value of the variable, which could be X, so it's the most popular one. That could be A, B, C, D, E, F, G, H, I. You get it. Last one is a formula. So name a formula we've already done before. There's the midpoint formula. What else?
Distance.
The distance formula. We've done an area formula, right? Name an area formula. Sure. So in a formula, the purpose is to find one of the variables. This variable represents what? The letter A. Represents the area. So in order to find the area, what would you have to do? Plug in things. Plug in the base and plug in the height. So the difference between a formula and an equation, a formula you're going to be plugging things in for all of your letters. Okay? So a formula, an algebraic equation that relates two or more real-life quantities. So area has either base or height or length or width. The midpoint formula had x1 and x2, and so on. So an algebraic equation that relates two or more real-life quantities. So the purpose of this lesson is to solve algebra, like you see on the bottom of your page, but also to explain and justify why you do what you do in an algebra problem. Okay, so there are 5 properties we're going to be using. The first one is the addition property of equality. So this is under core concepts. You'll see a blank here. You're filling it in with addition property of equality. So you're filling it in with addition property of equality. Your page literally looks like mine. So here's where you're going to take your highlighter. So not quite, but when I say of equality, you've heard this all in math. What you do to one side, you do to the other. So the reason we're calling these properties of equality is because we do them to both sides. To both sides. So here's what you're going to highlight. This is called the addition property of equality. The part that makes it of equality is that you're adding the same thing on both sides. So you're going to highlight the plus C and the plus C. So this is what makes it the addition property of equality. Looking at your paper, what do you think the next property is? The subtraction property of equality. You can go back and highlight at the end. The next property would be the multiplication property of equality, and then the division property of equality. So again, the reason this is a property of equality is because you're doing it to both sides. The of equality is important because there are many addition properties, multiplication properties, subtraction properties. So this specifies this is an equation, and what we're doing to one side, we're doing to the other. All right, so the last one will be used on every single problem. So the last one is called the substitution property of equality. So you want to note that this is the last step on every problem. Last step. So anytime you get down to x equals 2 or x equals -8 or a equals whatever, that is your substitution property, meaning 2 could be plugged in for x and any other variation of that. So here's what we're going to be doing. I'm going to give you a very simple example before we move on. I have x plus 1 equals 8. Your directions would say solve and justify. When you're justifying something, what are you doing?
Making it right.
Not quite.
Proving.
You're what?
Proving.
You're explaining why you did what you did or why you believe what you do. So, here's what we're going to do. Our first step to solve this equation is subtract 1. So you would subtract 1 and then write off to the side that we're using the subtraction property of equality. So if you notice, I did not abbreviate subtraction except for to subtract. I don't want it any shortened other than subtract, especially to sub. Why would I not want sub? Yeah, there's 2 of them. There's substitution and subtraction. Okay, so you'd write this on the side. You would keep solving. X equals 7. So anytime you get down to this last step where you have x equals a number, okay, you're going to write the substitution property. Substitution of equality. Make sense? This is what you're going to be doing. Let's look at the problem on the bottom. Yours has 2 columns. One column is for the math. One column is for you writing the step. What are you confused about, bud?
Can you go back?
To these?
No, the thing we just did.
It won't come back because I drew it. What part of it did not make sense to you?
Oh, I just didn't finish writing the properties.
I wrote subtraction property and then substitution property. Because we subtracted first and then we got to our answer. So our problem says solve 3x plus 2 equals 23 minus 4x. I always move the smallest x first. So here, what will be the smallest x? Negative 4x. How do I move it to the other side? Add it. So as I add it, I'm just going to write that I'm using the addition property of equality. So you have to solve it too. What would my next step be? Subtract 2. So then again, off to the side, I would write which property?
Subtraction.
Yep, so subtraction property of equality. So that gives me 7x equals 21. What's my next step? Divide by what number? 7. So you can shorten that to div property of equality. So then I get x equals 3. So that's a substitution property. Good. That's it. So you'll be solving irregular equations, and you'll just be telling me what steps you're doing. That's it. Go ahead and flip when you are ready. This needs to be 21. Because you subtracted 2. Alright, so if you see core concept, there's another property. Can anybody take a guess at what property? Oop, I already said it. What's the property? Distributive. So in your blank right here, under the word core concept, you're going to write distributive property. It is not a property of equality, because you don't do it to both sides. You just distribute. When you're distributing, are you adding, subtracting, multiplying, or dividing? You're multiplying? Okay. So when you distribute, you do a times b, then a times c. Same thing here. A times b, and then a times negative c. All right, so you knowing that, we're going to do our problem. This is at the bottom of that page. What's my first step? Distribute. So minus 5 times 7w is negative 35w. Minus 5 times 8 is negative 40. So that is my distributive property. So again, it is not of equality because you did it on one side. What's my next step? Add 40. So that's my addition property of equality. What's 30 plus 40? 70. So after that, my next step is to divide by negative 35. So that's the division property of equality. So when I divide a positive by a negative, what's my outcome going to be? Negative. And then what's 70 divided by negative 35? Negative 2. Good. And then your last step is substitution. Property of equality. All right, when you're ready, you can go ahead and flip. There are 3 geometric properties we use often. The first one is reflexive. So reflexive is when it kind of repeats itself. It's like redundant. A equals A. The length of AB equals the length of AB. The measure of angle A equals the measure of angle A. So the first property is reflexive. The second property is symmetric. So it's going to, you use this often. For those of you who don't like, if the answer was 4 equals x, some of you don't like the way that looks, so you flip it to x equals 4. That is the symmetric property. You'll see here, if A equals B, then B equals A. If AB equals CD, then CD equals AB, and so on and so forth. You just flip them. These are the 3 boxes in this page, just so we know. The last one is the transitive property. I will explain it with a real life example. You don't use these very often. Just throwing it out there. So let's say that Talmadge and Kayla were the same age. We can also say Kayla and Vonasia are the same age. So then what can you guess about Talmadge and Vonasia? They're the same. So if these 2 are the same and these 2 are the same, the first and the last are the same. That's all the transitive property says. Okay? So, this is what 2 problems on your homework will look like. It'll already have it filled out. You just need to decide what they did between each step. Okay? So between step 1 and step 2, what happened? They distributed. This is the next page. So you're going to go ahead and write distributive property. Because they distributed, that's how they got 2x and then 6. Between the next 2 steps, what changed? Yeah, they subtracted. So pause before you start writing subtraction. Did they do that on both sides? No. So we're not actually going to write the word subtraction. Here's what we're going to write. What do we call it when... It is called simplifying. Starts with a C is what I'm looking for. Close. You're combining like terms. Somebody said combination. That's close. Combine like terms. So they combined 6 minus 5 to make 1. So they combined like terms. The next step, mine's in color, yours is not. What'd they do to both sides? Yeah, they subtracted that 2x. So which property is this? Subtraction property of equality. I can't fix it. It just is what it is. So this next one, we go from 2x minus 2x to nothing. We go from 5x minus 2x to 3x. So what are we going to call that? Combining like terms again. So that's all we did was combine. right, next step, what did we do to both sides? Subtracted 4, so that's the subtraction property of equality. All right, and then what changed between these two steps? They combined again, yeah. We're almost there. They divided 3 on both sides, so that's called the division property of equality. All right, then they came to an answer, minus 1 equals x. So which property is that? Substitution. And then in the last step, they flip-flopped the x and the negative 1. So which property was that? The symmetric property. Good. Awesome. We have a one-word problem to do together. So if you're taking the PERT test, there'll be something like this. I'll explain why after we read it. You get a raise at your part-time job. To write your raise as a percent, use the following formula. So we're going to go ahead and write the formula down. Resist the urge to try to solve it because I'm going to guess you're going to solve it wrong without me. So just leave it. It says where P is your previous wage. That's important. R is the percent increase. It's written as a decimal. And then N is your new wage. So it's going to ask us 2 things. The first thing is to solve for the letter R. This is why I told you to wait for me. What is your first instinct when you see a problem like this? What do you want to do? Distribute. You should not. Here's why. Our final answer, we want R to equal something, right? This R is already 1R. You know how we don't write a 1 there? It's invisible. It already looks the way it should. The only problem is it's attached to R plus 1, and all of that is being multiplied times P. You don't want to distribute, you'd make your problem harder. Because when you distribute, you'd have P times R, which is PR, and that's not going to help you. So here's what you want to think about. What is the letter P doing to the parentheses? Multiplying. If I wanted to get rid of the letter P that is multiplying, I have to do the opposite. So what is the opposite of multiplying? Dividing. So you're actually going to divide both sides by the letter P so that you can cancel it out on the left. So we cancel it out on the left. All we have is R plus 1 on the left. And then what do we now have on the right? N divided by P. All right, so now we are 1 step away from solving for R. What do we need to move? The 1, so we're going to subtract the 1. Can you subtract a number from a letter? No. So we're just going to write them next to each other. And that's, we solve for R. That's it. It's not a pretty answer. It's not going to be a pretty answer. But we did what we were supposed to do. We got R by itself. The second half asks, what is your wage written as a percent when your hourly wage increases from 7.25 to 7.54 per hour? So what did R represent here? My percent of increase, right? What are we trying to find? My percent of my hourly wage increase. So if I solved for R, if I plugged in everything I knew and solved for R, I would have the answer. So I'm going to write the formula again. and plug in the numbers that they gave me. Okay, because they gave me how many numbers in this? 2. Okay, so we're going to talk about it. So to find my raise, written as a percent, I'm going to plug in, what did N stand for? My new wage. What's my new wage? $7.54. And what did P stand for? My previous wage, which was $7.25. So I've plugged in everything I need to. Now I just solve. What is 7.54 divided by 7.25? Yep, 1.04. Subtract 1. So what is the rate of increase? 0.04. Did it ask for it as a decimal? Did it? What is your raise? It says right here. What is your raise written as a percent? So we need a percent. We're going to move the decimal over. Good. So move the decimal over, and what percent is 0.04? 4%. Good. You're going to take out that 2.1 to 4 review real quick. We're doing this next problem because it's similar to the one on the homework. The homework problems are not this hard. This one is difficult. But when you get to the homework, I want to make sure you can do it. You're going to write down this letter A. We're going to do it together. So again, this is on 2.1 to 4 review. So the paper we started on before. Because again, on the homework, you will have to do a problem like this. So the paper we started with, yep, right there. Okay. So what is our goal? What do we want to solve for? Y. Do I need to justify each step, or it doesn't say it? Doesn't say it. So I can just solve for Y. What is Y immediately attached to? Not just 2. Negative 2. So I need to get negative 2Y by itself. So what do I need to move to the other side? The 3x. How do I move it to the other side? Subtract it. Can I subtract a letter from a number? No. So I'm just going to write them next to each other. I'm going to do x first and the number second. There's not really a rule saying you have to. It's just what I'm going to do. So now I have negative 2y by itself. What is the negative 2 doing to y? It's multiplying. So the opposite of multiplying is dividing. So I'm going to divide each piece by negative 2. This is so I can simplify. What happens when I have a negative over a negative? Yep, makes a positive. And then can 2 go into 3? No. And then same thing here, the negative over negative. We're going to have a positive. And then what's 16 divided by 2? 8. Good. You can go ahead and take out your textbook. You cannot leave without completing the first problem.